So this is worksheet 8. We're going to talk about solving by graphing, and then on the back, we're going to hit some fun application problems. Okay, so I don't really have a warm-up other than the fact that we're going to revisit this solving by graphing thing. Okay. Could someone turn the light off next to the phone so you guys can see better? Okay, cursor would be good. Okay, I think I'm ready to go. Here we go. We started this yesterday, but the intersect method is when you put the two separate sides of the equation into two separate y values on your calculator, and then you find the intersection point. Thus called the intersect method, okay? So x minus 2 is going to graph as a line. Negative 1/2 x squared plus 2 is going to graph as a parabola, and I'm going to put some parentheses there. I'm going to go ahead and do this. Was x minus 2, and the other one was negative 1/2 x squared plus something. Guys, it's underneath. Help me out. Thank you. Okay. I'm going to start with just a zoom 6. Looking pretty good. I could even totally cheat and do this for my sketch. I know you can't do that. Don't hate. We talked about this a little bit yesterday, but it will eventually on quizzes ask you to give the windows. So we just did negative 10 to 10 and negative 10 to 10. This method, we're trying to find where they intersect. So if we go back to the calculator, we do second trace, choose 5 for intersection. We can just hit enter because it says, is this the first curve? X minus 2. Yes, it is. Is this the second curve? Negative 1/2 x squared plus 2. Yes, it is. For guess, if you wanted to find the one over here, you need to be closer to that one. Okay. So this ordered pair over here is 2, 0. What do we write down, though, for an answer? Yes, because the equation originally only had an x in it. So we just want to know at 2, this side will equal 0 and this side will equal 0. So the equation will be solved. Okay, so x equals 2 is a solution. If I go back here to second trace, intersect, enter first curve, enter second curve, guess, this time I want to find one over here. I can scroll to the left till I get over here, or it looks like it's somewhere around negative 4, so I'm just going to type in negative 4. Hit enter. Yeah, nope, didn't need to hit enter again. Messed that up. It should say intersect when you're done. So there, it says intersection is at negative 4, negative 6. And again, the fact is that x equals negative 4 will make each side equal to negative 6, so they will be equal. So the two solutions are x equals 2 and negative 4. All right. Any questions? I know we did that one yesterday. Let's try this one. Can you type this one in? What are you going to put into y1? X squared minus 4. Please be doing this, guys, because the back, we have to be really good with the calculators by the time we do these applications on the back. Then it's negative x squared plus 4. Can you think about those graphs ahead of time? They're both what shapes? Parabolas, yep. One's going to be down here, and one's going to be like this. And then we're going to use, just use negative 10 to 10 and negative 10 to 10 or zoom standard. I think we'll be okay. Does it work, guys? Am I remembering this problem correctly? And then if you do second trace, and choose intersection. What do you get? Was it x squared minus 4 and negative x squared plus 4? Am I remembering right? So the intersection points, one of them is at positive 2. For my guess, to find the other one, I have to scroll over closer to that one. And I get negative 2. Everybody all right? I know I went fast. Is anybody not getting it to work? Rebecca? No? You okay? Anybody? All right, the second method is called the x-intercept method. It would be easier to call it the 0 method because we're going to use the 0 function. Okay, this one is already set equal to 0. What shape should this be? It's a parabola. Because of that 7, I'm thinking it's pretty narrow, right? And I'm not too sure my standard window is going to be the best. Because the y-intercept is what? Negative 15. So I think I'm going to change my y min to like negative 20. I left the rest of it. Okay. How are we doing? Too fast? Got it typed in? Okay. Now, if you remember from yesterday, my suggestion was don't spend a lot of time scrolling around. If you pick second trace and choose choice 2 for 0, it has a 0 somewhere between what two values on the left over here? Negative 3 and negative 1, and you do have to say the leftmost first. But you can type those in instead of scrolling around. It's really nice on the new color calculators because it actually gives you a line down the screen, not just a little arrow at the top, so you can tell that it's falling in between there. I got negative 2.05. Did someone else get that? All right. And then if I do the same thing, second trace 0, this one over here is somewhere between 0 and 2, looks like. And I got 1.046 or 1.05. Any questions on those? Somebody not getting those values? You can trace around. Anybody having trouble with left bound, right bound? Okay, I think I told this class the cheat yesterday. Maybe? Does anybody know a cheat for this? I could put in y equals 0 in one of these, and then I could really cheat and use the intersect method because I just like that one better because I don't have to do left bound, right bound, right? Okay, but it is intersection then. All right. Can I skip drawing all that stuff on there? All right, this one, in order to be able to use, they want us to use that same method. It has to equal 0 first. So we're going to subtract an x squared over here. Can you guys type this in? I know we did it yesterday, but subtract an x over here. Add 9. Is that negative 24 then, guys? Anybody write that down yet? We're going to put this in to y equals, but what we really want to know is where does it equal 0? So we're going to use second trace and use the 0. And then we're going to say between what values. Now, I don't know what kind of a window we need for this. It works with a regular window? negative 83x squared plus 98x. Did I do my algebra right, guys? Someone else moved them all over and got the same equation? If I do zoom 6, yeah, this is not looking very friendly to me. What do I not need? Did I do something wrong? I don't need so much x, right? I want to spread the x out. So, I don't know, negative 4 to 4, negative 5 to 5, negative 2 to 2. That's enough that I can tell there's two separate ones, right? They're really close together. Is someone else getting this, or okay. So let me quick take a picture of this. I don't want it on a new page. So my window is just negative 4 to 4 and negative 10 to 10 for the y. I'm not sure that's a great window, but it should be okay. So now if I go second trace and I choose 0, I need to clearly be on the graph somewhere here. There we go. There's my cursor. I'm really close to where I think the 0 is. So if I go a couple to the left and then a couple to the right, the important thing is it has to cross in between those two boundaries I picked. Otherwise, you'll get an error that says no sign change. So I got 0.3467. Did anybody else get that? No? Yes? This method is easier for students to understand because it says equals 0, right? Or did anybody get anything goofy like negative 1 times E99 or E negative 99? You know what I'm talking about? Sometimes it doesn't come out exactly 0. All right, I do want to show you what that error would look like. If I was trying to find a 0 and I said it's somewhere between here and here and I didn't cross, it'll say no sign change because in between where I put my two left and right bound, it does not ever become negative. In order to be a 0, the calculator wants a sign change. That gets to be an issue for us when we do bounces. Do you remember when a polynomial bounces off? Sometimes we have to be a little bit careful about finding the zeros then. All right, one more time. This is left. If I go to the right, it clearly crosses. And I got 0.834. Anybody? All right. I don't know. It didn't say how many places to go, so at least I didn't notice it did. So I'm just putting something down. Are we okay? We could have solved that exactly by quadratic formula. Wouldn't that have been fun? All right. Eventually, because we have a graphing calculator, we can solve all kinds of polynomials and find the zeros for things that I could not do when I was in school, okay? Because we didn't have graphing calculators. All right, this is an application question, and it's a really good application question that could be on a test or quiz when we have one, the next quiz. If an object is dropped from a height of 96 feet, the function here gives the height after it's fallen for t seconds. So we're going to put into y1 negative 16x squared plus 96. Why doesn't this have a middle term? Does anybody notice what's different about this than the one we did yesterday? Why it doesn't say like plus 112 or minus 112x in the middle? Ariana? Yes. Yeah, it doesn't have any initial velocity. It's why there's no middle term. Do you know what I'm talking about, guys? Okay, so it's just being dropped. There's no initial velocity. All right, so I'm going to put it in. You are absolutely right what you said, Ariana. I just wasn't phrasing the question well, so you knew what I was even asking. I apologize. Plus 96. Okay. What's an appropriate window? Because this is an application. Can we have negative time? No. It's probably going to hit the ground by 4 seconds, so I think I'm going to leave 4. It's only dropped from, what, 10 feet? Was it 96? Oh, I don't know. I'm going to try that. Okay. What about my Y? It was dropped from 96, so I need it to go up to at least 100. All right, my window turned out pretty good. All right, so again, here's my window, 0 to 4 and negative 10 to 100. You don't have to have exactly the same window. Any questions about what would be an okay window? This time I'll sketch, I guess. Okay. What are we trying to find now? How long until it hit the ground? How do we find that? Second trace, and what are we looking for? We're looking for the 0. Okay, looks to me like it's somewhere between 2 and 3 seconds. So we get 2.45. Now, is anybody confused about that? The X is time, right? And the Y is height. Okay. Do we know how far away from us this landed? That's not what this equation determines. It just determines time and height off the ground. We will eventually do some, and it's really fun when we do the ones where you shoot something at an angle and do all kinds of crazy business. Oh, this was supposed to be up here. Any questions on side A? I think that's it for side A, isn't it? Okay, side B. We eventually do a lot of these box problems, but this is a pretty basic one. It says a box with a square base and no top is made from a square piece of cardboard by cutting 6-inch squares out of each corner and folding up the sides. Okay, I'll draw this and then I'll make a model for you, but they can't see that on the video. If I have a square and I cut the corners out, and then I fold it on these red lines right here, that will be the base. Okay, if I look down into the box, that would be the base. If I draw it in perspective, it would look something like this. My picture is not good. That's horrible. I can do better than that. Okay, this is the folded up box. If the square, okay, we don't know how big this original blue square was. Okay, these little squares we cut out were 6 inches here by 6 inches here. What does that have to do with this box when we fold it up? What does that 6 inches become when I fold the leftovers up into a box? So what was left looked like this. And I folded it into a box. Something's 6 inches, but it's not the sides. So we had a square. We cut perfect squares out of the corners. And we took what was left and we folded it into a box and taped corners. Okay. Everybody see what we're doing? Okay. So this was 6 inches. Yes. When we folded the box up, it became the height. Do you see that? better when I do a physical model? Okay, so this 6 inches right here is this 6 inches right here, which when I fold it up became this 6 inches right there. Does that help? Okay. We don't know how big the original box was. That's what we need to figure out. So we're going to call this X. So this was originally X, yes? But when we cut it down, what is this new dimension here? Oh, let me make it green. What is this green right there? I heard an X minus 12. Where did that come from? This was X. We cut off 6 here and 6 here. So what's left is X minus 2 6s or 12. Does everybody see that? And this one, luckily, is the same. Let's hold up the model again. If the whole thing before I trimmed it was X, I went in 6 this way and 6 this way. What's left here is the X minus those 2 6s, yes? Okay. How do we write volume? So length times width times height, or if we were typing it in, we could write 6 times x minus 12 squared. Would that be a faster way to put it in the calculator? And what does it have to equal? It needs to hold 1,000, so we want this to equal 1,000. Now we could solve that algebraically, honestly, pretty quick, right? Divide and square root. We're going to do it by graphing. And into y1, I'm going to put 6x minus 12 squared, and into y2, I'm going to do 1,000. The reason we're going to do it by graphing is eventually we're going to do ones where we don't know the size of the corner that we cut out either. We know the size of the original, and then you have to do them by graphing because you can't do them because they're cubics. All right, so (parenthesis x minus 12 quantity squared), and I wanted to hit 1,000. So I'm going to put in y2, just the number 1,000. What does that mean I need my window to go up to? 1,000. Okay, I'm going to make my y min negative 100 and my y max, I don't know, 1,400. Kind of want to see the top of this thing. My x is how big the original thing was. And what do we know about it? It had to be more than what? Had to be more than 0, but it honestly had to be more than 12 because we cut 12 off of it. So it's going out pretty big. I'm going to put, I don't know, 50? Is that way too big? I have no idea. Okay. So my window, I could have gone like 30. All right, this is a pretty good window that I have going here. I don't remember what I have for a window. Let's go back here. I have 0 to 30 and negative 100 to 1,400. For my X and Y window. So what do I want to find out of this mess? Yes, I want to find what dimension of X made it hit 1,000. So if I find the intersection point, I get 24.91. Anybody getting that? So it has to be, if it says the box needs to hold, if it's supposed to be exactly 1,000 cubic inches, X would need to be about 24.91. Remember, X was the size of the cardboard box to start with. So I'm going to write that so we remember. Original cardboard needed to be 24.91 by 24.91 inches. Are there dimensions that won't work for this? This is the volume of the box. Can we have it hit 0? Remember, we said it really needed to be more than 12, right? Otherwise, we couldn't cut in more than 6. We couldn't cut in 6 and 6. All right, we'll talk more about that later. Let's go on to another kind. A farmer wishes to enclose 3 pens with fencing as shown. If the farmer has 700 feet of fence to work with, what dimensions will maximize the area enclosed? All right. So when he goes all the way around this mess, he's going to have 700 feet of fence. I don't know if these are supposed to be squares. I'm going to call this X and this Y. And this Y, and this Y, and this X. So what is the area of this thing? X times, how long is this whole thing? Would you add or multiply those? Add, right? So you'd have 3Y. What about the perimeter, the amount of fence needed? You got to add up all of this, right? What does he need? 4 X lengths and how many Y's? 4 X's plus 6 Y's. Okay. What does he know, though? He has 700 feet of fence. Okay. I can't do this with 2 variables in my calculator. I need to maximize the area up here. So do you want to get rid of the X or the Y in this equation? Doesn't matter. Okay. Let's get rid of the Y because we're used to typing X's in our calculator and be less confusing. So I need you to solve this for Y. What would you have to do to get the Y by itself down here? 700 minus 4X, and then what? Divide by 6. All of that is going to be Y. Anybody want to cry about now? And we're going to put that back in here. So I'm going to have X times 3 times 700 minus 4X over 6. Can I reduce that a little bit? Could that 3 and the 6 reduce? So I have X times 700 minus 4X, and that's over 2, but it doesn't really, so we can put it in like this. And then we need to find the maximum. X times 700 minus 4X divided by 2. Okay, X is how wide and Y is how long. Now Y is the area. I don't know, 0 to 50 and 0 to 1,000. Is 1,000 too much? I'm not even sure what's reasonable. Yep, I am nowhere near. I'm looking for a maximum. Anybody getting anything to work? Oh, I'm getting there. Maybe I have something typed wrong. Is everybody's window this big? Okay, I'm stopping. Hey, so I have 0 to 250 and 0 to 30,000. And I'm looking for a maximum. And I just messed it up because I need my left bound to be over here somewhere. Everybody okay with finding a maximum? Somewhere between here and here. So I have 87.5 roughly. Did anybody get that the maximum occurs at 87.5? Okay, can anybody tell me what my window was again? 0 to 250 and 0 to 30,000, is that what I had? And then I found maximum up here, and the maximum occurred at, what did we get? 71.5? 87.5? Okay. So what are the two dimensions? Well, this dimension is 87.5. How do we find this dimension? Multiply it by 3. 87.5 times 3. Anybody helping me out? Okay. That was a disgusting question, yes? Okay. There's not one like that on the first summative. How did I get 262.5? The dimensions were x by 3y. X by 3y. So, okay, hang on. If this is x, yeah, I don't think that's right, is it? No, it's not right. Okay, hang on. We got to go back. We got to plug it back in here to find y. Can you do this? 700 minus 4 times, or up here, doesn't matter, but, or just take the area and divide. That would be faster. Can we take the area? I think we should have just assumed it was 3 squares. What do you think? Divided by 6. Did anybody get 58.3? But that's only one of them, right? Then you got to multiply that by 3. Oh my gosh. So it comes out 175. Okay, hang on. 87.5. 87.5 times 4 plus 175. No, plus, oh my gosh, I'm making myself crazy. We want to know what 3y is when we're all done. We should just started with calling this y. I made this problem way too hard. We should have just called this x by y. Yep. All right. We're going to come back to this question. This is, I made it way too hard. We'll come back to it. This is what's on the quiz, is a question like this, okay? Yeah, it's right. It's just, I made it way too hard. A salesperson finds her sales average 40 cases per week when she visits 20 stores every week. So when she goes to 20 stores, she sells 40 cases to every store manager. So she sells a total of 800 cases. Everybody okay so far? If she visits an additional store, so she decides she's going to go 21 stores, she chit-chats a little less. They get a little less happy with her, and her sales go down by 1. So this goes down to 39. Okay? What's 21 times 39? What is it? 819. Okay? If she goes to another store, this is going to do what? Go down again. What's 22 times 38? 836. Okay? I want us to do this algebraically. Can anybody tell me what's happening over here? So if we call this 20 plus what? X? What does X represent when we do that? That's really important that you know that. Number of additional stores, right? Okay, what is happening in this column? And 40 is minus X. If I multiply those two things together, I get the number of cases, yes? And I get a quadratic, which is opening down because of that minus, so it has a maximum. We are trying to maximize the revenue, so we need to find the maximum of this. Okay, if you want to do it by graphing, type it in your calculator, but you're going to have to think about an appropriate window. Could also FOIL it out and do negative b over 2a. When we put this in, it represents oh, that's supposed to be an X. X is the number of additional cases, but the total product of those two things is how many she sells. So what did she start off selling, guys? 800 cases? So is this going to have to go up pretty high? I'm going to put 1,000. I don't think it's going to go over 1,000. I could be wrong. But X represents how many additional cases. So I don't think X needs to be very big. I'm going to try just like 10. Yep, not a good window. I'm going to try like 50. Okay, so here's my window that clearly has a maximum in it. I have 0 to 50 and 0 to 1,000. How did I know? How did I know I was going to need to go up to 1,000 or somewhere high? Because this is number of cases, additional cases, and this is number sold total, and it was already at, what, 800 or something? Okay, so when I do that in that window, I get this, and I'm interested in this maximum here. Can you find the maximum? It's somewhere between 0 and 50, because it's in that window. I got 10. 9.99999 is just a calculator error. Did anybody get 10? Okay. This maximum occurs at 10, was it 10,980? 900? Okay, couldn't see. 10,900. Is the answer how many stores per week should she visit is not 10? This is where everybody gets this question wrong. They do all this work on the quiz and they put down 10. How many stores should she visit? Yeah, 20 plus 10 is 30 stores. That would be 40 minus 10 would be 30 cases she would sell, so she'd max out at 900. So the answer is 30 stores. I'm not going to write a full sentence just because I'm out of room. Now, I was really nice on the quiz. I put like total number of stores to visit to help you remember that you have to add it back on, okay? Just giving you a hint. All right, let's try number 9. This is the same kind of question. A potter sells currently 120 bowls at $4. So right now, this potter is making $480 in revenue. For every 50 cents that he lowers the price, so if he goes down to $3.50, 20 more bowls will sell, so we'd be up to 140. Can someone do 140 times 350? Be 70 times 7, 490, I think. Okay. So can we think about what's happening? This one is going up by how much? 20. And this one is going, $4 is going down by what? 50 cents. So X is actually every price decrease. Because that's what he said he was going to do. He or she was going to drop the price 50 cents. And that will give you the revenue. All right. You will not get full credit on these unless you set up an appropriate equation. You can find the answer by just keeping to try points. Though I think the one on the quiz, I tried to make it so you would be trying for a while. Would be trying for a while. Because I want you to do it algebraically. This one, I think we probably already found the maximum, did we? Am I wrong? Can he increase? How many times can you increase the price or decrease the price if you're only at $4 and you're going down 50 cents? 8 times till you're giving the bowls away. So 0 to 8. And 490, so I don't know, 550 maybe would be the maximum. Yes, I got a maximum in this window. No. Or I did something wrong. I have 120 plus 20x and 4 minus 0.5x. And then I did 0 to 8 and 0 to 550. And it's kind of hard to tell, but the maximum, and you can just tell the calculator, I want to find a maximum between 0 and 8. And it says it's at 1. Because like I said, if he did another set of 20 here, and this went up to 160 and this went down to $3, that's 480. So it's headed back down. So the maximum price is right here. Okay, so the question was, what price should be charged in order to maximize revenue? $3? Yes, $3.50. And then max revenue would be, you don't need to state that, but max revenue would be $4.90. Is there one more of these on here or no? Okay. I'm going to go back. Oh, your homework, guys, is to do the circled problems on worksheet 9, okay? Both sides. I'm going to go back and talk about this question. You don't have to write this down. We should have called this X and this Y. So we would have 1, 2, 3, 4 X's and 2 Y's to build the fence. So then the total area, guys, would be x times 350 minus 2x, and the whole world would have got so much better. I know! Hate! I'll go over it tomorrow again. I totally messed that one up. The dimensions. You're trying to find the dimensions of the whole enclosed area. So that's why you should just call this X and Y. Yeah, that's too easy. I don't want it to be, yeah. Yes.